Hi, my name is Alex Williams, founder of the New Stack, and you're listening to the New Stack Analyst Podcast, a show about application, development, and management at scale. Thanks for joining us. Apache Mesos and the multi-cloud is the topic of discussion in this episode of the New Stack Analysts. We'd like to thank Intel, our sponsor for this week's show, and also the sponsor for the Pancake Breakfast that we did from MesosCon in Denver, Colorado, where this conversation was recorded. Learn more about Intel's vision of the multi-cloud and the future of software-defined infrastructure at intel.com. Good morning, everyone. I'm Alex Williams with the New Stack. And we've been doing these pancake breakfasts for, I think about a year now. And we usually would come to an event like this and serve pancakes and have a discussion like this. A few months ago, I ran across PancakeBot on it started as a Kickstarter campaign, and they just started selling them. And so we bought one about a month ago. And we just think it's just a natural addition to our pancake breakfast events. And so what the plan at least is that we're going to continue to print pancakes over here. We printed out the Apache Mesos logo. We got close, so this is still very much in beta. But we're having a lot of fun with it. And one of the things that we're going to do is if you ask a question, we'll give you a pancake, okay? But it's actually been pretty interesting, and to go through this process, and but before I really get started with that, I really want to thank Intel for sponsoring this pancake breakfast, and for Apache Mesos community for making this possible, and to the panelists here who are joining us for this discussion. And the topic is Mesosphere in a multi-cloud world, and I think of it more. And kind of in thinking through this discussion, I wanted to really think about PancakeBot and how it applies kind of to this whole new world of the Internet of Things. And how are we going to start managing tens of thousands of PancakeBot-like machines, be they anything. And because as we are starting to understand, everything can become a node at some point. The table, the chairs, and so you start. I wrote a story, I remember like a few years ago, asking that question, is this really a table, or are these really chairs, or are they just data objects? And so the question then, I think for us is, with that in mind, we're just trying to deal today with just incredible complexity. And whenever I talk to people about the complexities, they all shake their head and say, yes, this is our reality. And so kind of considering that as our reality, I wanted to talk about the complexities that we all face, and especially I'm interested in what the panelists are experiencing, and how they're understanding it, how they're understanding complexities, and how the role of Mesos plays in terms of those complexities in this new world that we're in. And so I'd just like to introduce our guests. We have Murali Sundar of Intel, who's with the Software Defined Infrastructure Group. We have Jessica Frazelle, hi Jessie, of Mesosphere, and we have Benjamin Hindman, Mesosphere, and the one behind the Mesos itself. So I want to just maybe start with Murali. Can you talk about kind of some of the complexities that you're trying to deal with in your own work? When you're thinking, I think these terms get often confused. Like, what is a multi-cloud anyway, right? I think we are more familiar with terms like multi-tenancy, right? Like, you're trying to understand, like, just in the simplest sense, how you kind of manage different types of clusters, right? Or you try to like move across different kinds of environments from one data center to another. So I'm thinking like, what is the work you're doing and what are the complexities that you're trying to understand in your own work?
Yeah, it's a good topic. Yeah, at Intel, we are no strangers to complexity. How do you deal with vast numbers of machines and vast numbers of services? Well, you build proper abstractions. And as long as the abstractions are reasonably flexible and adhere to certain principles or a model, then you can innovate under that and keep the complexity in check. Now, within that model, of course, you want to also expose the uniqueness of the platforms that you're working on. Otherwise, you end up with basically the lowest common denominator, and that doesn't serve anybody. So at Intel, our model is really build proper abstractions, enable the industry to innovate on the platform so that you get the best of both worlds. You get the complexity, but handled through good abstractions like Mesos.
So Jesse, in terms of the complexities that you're working on, you're working a lot on container security, right? And so, I think of container security, I think of how we kind of think differently about the way, we approach security now, right? So the approaches are a lot different, aren't they now? And I'm curious on how you're trying to understand what those approaches are and, the work that you're doing.
Yeah, so, there's a lot around there because you can use things like Linux security modules, and now there's added things like seccomp profiles where those get very complex because you have to define the syscalls themselves, and a lot of people, at least the devs building the app, might not be as familiar with low-level syscalls as they are with like what their app actually needs. So yeah, I think a lot of abstractions in terms of making this easy and fun to almost secure would be great. But also just when it comes to multi-tenancy of a cluster, like securing your cluster is insanely difficult because there's a lot of things to manage when it comes to like authentication, authorization. When you have multi-tenants, like separating out who's using what, are you sharing certain things and not other things? What actually gets used by someone, auditing all of that, like where are you storing your secrets? It goes on and on.
Yeah, I think, Ben, you touched a little bit about this in your keynote yesterday when you were talking about, all the things in Mesos, right? It's not just the frameworks, right? It's the installers. It's I think it must be the authentication and all those kinds of matters. Like so, yeah, in terms of that, what are those kind of things you're working on right now to understand how you manage authentication, how you manage these other issues that Jesse and Murali are talking about?
Yeah, so for the Mesos project itself, complexity has been something that we've thought about from the early days. I think as we were talking about abstractions, that's been a big part of it. We wanted to kind of keep Mesos small and as not complex as possible. And a lot of this actually came out of just a desire to be able to debug the system when you're running on tens of thousands of machines. The more complex something is, the much harder it is to actually debug it. And then also add new features. The more complex things become, the harder it is to go and actually add new features. And one of the things that I think the Mesos project does a pretty good job at is refactoring when we add new features. And it's really, really hard to there was a great article that I read not too long ago, which was basically talking about the idea that when you build software, you pick an abstraction. At that point in time, that abstraction makes sense. 6 months later, when you're trying to add some new feature, the abstraction might be a little wrong. You'd like to change the abstraction, but you still want an abstraction, and so you have to refactor. And the more complex that your software is, the harder it is to actually do that refactoring, which means you just kind of bolt on something to your abstraction, which doesn't exactly make sense, and you just keep doing it and doing it and doing it. At the end of the day, you don't really have an abstraction, you have a monster.
Yeah.
And then when it comes to actually debugging something like that in production, it's just crazy. So yeah, and then from the Mesos perspective, complexity has always been a really on the top of mind of a lot of the committers and a lot of the people in the project, and we've tried to kind of stay away from it as much as possible, which has really led to this more stratified sort of layering approach of having things like Mesos and then having other things around it. That served us pretty well for being able to get this stuff to run and work reliably at big scale.
So what's the lesser monster in this world? That's my question. I mean, one of the reasons we're trying to do these things is to deal with the monsters that we already have, like in terms of, these big monoliths that are trying to use to to scale operations, which don't exactly work the way you would like. So I'm, are there, so you're talking about these new monsters that you can end up creating. What are some of the monsters that you're trying to mitigate with that? It's kind of monsters is kind of a term that's fairly abstract, but it does speak to the complexities too, doesn't it? Murali, in your everyday work, what are those, how are you balancing what you're actually doing to create something which might become a monster in itself versus what you already have, which is a problem as well?
Yeah, that's a wonderful question, actually. In fact, the reason for the SDI, Software Defined Infrastructure group that I'm in, Intel totally understands that everything is becoming programmable and software defined. And what we are trying to do from a managing complexity standpoint is offer the proper platform primitives so that a higher level orchestration software can do the right things to bring the complexity in check. And a good example is contention for resources within a platform. If you can call that a problem or a monster, as you will, if you will, the problem there is there are resources on the platform that are shared by multiple tenants, and if you don't have the proper abstractions again to properly isolate these things, then you have the makings of a problem, right? Which is one workload stomping on the other, and there are actually multiple talks yesterday about that, and I have one today in the last talk of the day where we talk about exactly this problem. How do you manage co-location properly so that the co-location doesn't become a problem in itself? If you just cram everything into one box and if everybody's stomping on each other, then nobody's happy. And then you again go back to the silos where, well, I can't really run my Hadoop jobs here because it affects other people. I'm going to silo it into a separate set of servers, and that defeats the purpose. So our job is, again, to build platform primitives and expose it to the upper level software so orchestrators can use it properly. And the resource director technology that Intel has recently announced allows you to do cache partitioning is an excellent example. CPU cache is a shared resource that is usually not controllable up until a few months ago, I would say, a few years, maybe a year ago. But Intel has added this feature now, so an intelligent orchestrator running on the node can actually partition that. So you reduce, again, interference effects and hopefully reduce complexity.
So, Jesse, in your work, how are you prioritizing complexity so you're not just creating something, that actually just creates more problems?
Yeah, that's hard. Coming from the open source world, it's nice though to have a set of users that you can get feedback from and almost test out new features on, so that if you're going in the right direction or if you're completely wrong. And yeah, I would just say getting user feedback and listening to the community is huge, because they're the ones that use the product and probably know what's best and actually have to deal with it day to day. Whereas you might dog food it and use it too and have your own ideas, but there's usually some perfect compromise there in what's needed.
So Ben, in the conversations you're having here at MesosCon, what are some of the discussions that are notable to you, and what are some of the themes that you were thinking about when you were looking at the discussions for the event itself? And I guess that's a prelude to asking, what are you looking at today, and what are some things you're interested in today as as the folks here go into the conference?
With respect to complexity, well, one of the things I was just thinking, so maybe I'll say that first, and then come back to that, because when I was preparing for thinking about the big complex things that we're trying to think about in the project. I think one of the things that, to me, one of the big monsters monster's the wrong word. but complex things that we're constantly dealing with is the right way to, given that a project like Mesos does care about reducing complexity, the right way to bring in community contributions. And that's a difficult thing because, as Jess was just talking about, you want to hear from the community about what the community wants and what they want to bring in, but you have this tension with that and not bringing in stuff that's going to drive the complexity of the project. And I don't know that any project has really exactly figured this out, but there's a quote that I really liked from Solomon from Docker recently at OSCON, and he was on stage and he said, no is temporary, but yes is forever. Mm-hmm. And I really like that quote because it's to me it really captures this tension that's kind of a monster in open source communities of sometimes saying no about bringing things in because you're not sure if you've exactly figured out the design yet, and you don't want to bring in something that's too complex because you're going to have to debug it in production, and you've got some big scale users that if you do go down, they're going to be unhappy with your technology and maybe they'll walk away from it. And so, you say, well, maybe no right now, let's keep working on this, but let's figure it out versus like, well, yes, we're going to do it and then we're going to support it forever. Anyway, that was the monster I was thinking about in my head. Uh-huh. And I think it's still a challenge with a lot of open source communities and figuring out the best ways to do that. And I forgot what the second question you asked me was. Sorry.
Oh, I just was wondering what you're looking at today. You're thinking, some of the themes that you were thinking about. The first part I was thinking about, the themes that you looked at when deciding what would be the presentations here. I mean, you weren't the only one in that decision-making process, but there are a lot of people.
Yeah, so I actually wasn't even on the program committee. I sort of gave some input to the committee at the end for, the talks were first selected by just people that wanted to attend the conference. It was completely open source voting, open crowd voting. Anyone could come and vote for the talks that they were interested in. And I think that actually that did a great job. If I would have picked the talks myself, I would have picked all the ones that people pretty much voted for. We added a couple, the program committee added a couple, and they kind of asked me for some of my input. And I think for me, the things that were most interesting was just getting a good balance between users talking about how they're actually using the technology, as well as some of the cool, interesting tech that's actually being developed. So, for example, we had a couple of talks on containerization, and I'm pretty sure those were already voted talks, but those are the kinds of things we're looking at to make sure that we're actually letting people know about some of the cool innovations that are actually happening in the project. There's another one around resource allocation, some work that's been going on with the folks at IBM, and again, very, very, very cool, innovative things that are happening in the project there. And so that was kind of some of the stuff that it was important to me to make sure that we had in the conference, because it's great to people be able to look and see some of the cool innovation that's happening in the project. I guess in terms of themes, I think one of the definitely big themes this year is people using frameworks to do things like IoT. And it's pretty impressive to chat with a couple of organizations that said, oh yeah, we had this set up before. It had taken us 8 months to get it set up, and now we have a new setup and we're doing it in a couple of days. And that I think is a pretty cool theme to see come out of the event. And there was a Verizon demo yesterday, an IoT demo, and there's going to be another demo this morning that's an IoT demo, and that's pretty cool to see that.
Let's take a quick break and then get back to the show. Intel is our sponsor for this week's episode of the new Stack Analysts and the Pancake Breakfast from MesosCon, where we recorded this discussion about Mesos and the multi-cloud. Learn more about Intel's vision of the multi-cloud and the future of software-defined infrastructure at intel.com. Now let's get back to the show. Ben, do we have any pancakes over there?
Got a question, Pancake.
We got a question, Pancake. So I'm curious, how many people are developers in the room here? Who would count themselves as operations folks? Who are both DevOps kind of thing, right? All right. Who has a burning question about complexity that they'd like to ask about the work that they're doing? This is, on security, for example, or this issue of multi-tenancy. Okay, great. You get a pancake. So hold on. All right.
I've been working for several years in the OpenStack community as a hands-on contributor, core contributor. One thing that we've used is when we have those features that we're not quite sure about, we would mark them and label them experimental. And by marking them experimental, what it said is, we're going to put this out there, and we could change it in the next release, we could rip it out in the next release. It's there for you to kick the tires, it's there for us to get some feedback and see if it fits. And it's sort of a try before you buy. And if you work that into your process, that kind of helps mitigate the concerns that you might have.
Yeah, I think that sounds fantastic, and I think there's a bunch of features that the Mesos community has been thinking about doing stuff in that way. The crux to me is being able to do that in a way where you can rip it out if you decide to later, and so that comes back to the abstractions. And so there's definitely been some features where people said, oh, maybe we'll want to do this, we're not sure. And so the engineering work has been to be creating the abstractions so that you could put this thing in, and then potentially take it out later. So I think that's a great I think that's a really good compromise, though, is to kind of put those abstractions in and then put the experimental features in, and then be able to try before you buy. Yeah.
Yeah. So we also did this with Docker. Like, there's a experimental release kind of. And yeah, I think it is great. Like, we started trying out with a few features like user namespaces and new networking in experimental, but it is still hard to say yes to things in experimental, because I think like a lot of the mood from contributors was like, oh, just merge it, it's fine. Like, but it still is going to be there, and ripping it out is going to be harder when patches land on top of it. So I think doing it the right way with maybe like a separate branch or something would almost be better, but yeah, it's like totally a good idea.
Any other questions right now? Here, great.
There's definitely like an incentive for cloud providers to create vendor lock-in, because if you truly have the flexibility to choose from any cloud, then it's more like commodity business for the cloud providers, and it sucks more for them. And it's certainly simpler to go with one versus many, unless you have proper abstraction. So I'm just kind of curious, like, what your thoughts are on the movement among the cloud providers towards the incentive to create vendor lock-in versus trying to be this flexible quantity that many people can use. Like, what are your kind of thoughts on that?
Yeah, any vendor would certainly like to retain their customers. So there's nothing controversial there. However, if you think of things like that, there is a precedence for all of this, right? For example, a lot of databases are proprietary mechanisms to interact with them. I've done that in the past. I'm dating myself here, but anyway, Paradox engines and all that. I've actually written code to ISAM, but then SQL as a language came along, and people kind of gravitated towards that. But then again, vendors added features. I don't think it's that big of a problem. I believe that users will demand the kinds of flexibility that they want, and vendors will offer them. Now, what is going to happen, I believe, is that different vendors have different areas of expertise, and it's entirely possible that they may offer completely different sets of services, that if your application depends on those, then you are making a conscious decision that, look, I'm going to benefit from some amazing, machine learning service that this vendor offers. And to that extent, I wouldn't even call that a vendor lock-in. It's a win-win. It's a trade-off that you make. So what I believe is that as new services are introduced by cloud providers and other folks, some amount of standardization is going to come up. And it's going to be like a lockstep thing. Okay, there is some new thing comes up, slowly the rest of the industry catches up, there is some kind of a common denominator, and then more innovation comes up. It's going to be like that. So depending on your business needs, if you're absolutely certain that you need portability, then certainly, in fact, the whole point of the container movement is somewhat of a nod to that need. Basically saying that, look, there's a common way of packaging and shipping things. You stick to this, you are portable to a good extent. And then if you use services offered by the service provider, then you have a little bit of a lock-in. So that's what I think is going to happen. It's not going to be an all or nothing thing.
Jesse, any thoughts on, on this idea of, we're talking about here, in particular about, working between different, cloud environments, so to speak, AWS versus Google versus data center environments, and how does that play out to you, and does that create a lock-in in itself?
Yeah, I think no matter kind of where you go, like everyone says, like don't drink the Kool-Aid and get like vendor lock-in, but like using anything is almost going to give you that unless you like have some sort of hybrid environment where you have a server on both. Like someone at the end of the day is lying to you about lock-in. Yeah, I guess like it's more like the tools that you build on top of your server, because as long as you're using something that works on multi-different environments, like even on-premise or like bare metal somewhere, then you should be good.
So it becomes sometimes an issue of support in itself, right? A cloud provider may choose not to support, for instance, Kubernetes or Mesos or whatever it is. I'm curious, Ben, from your perspective. To me, when starting to think about multi-cloud, I'm also thinking about the community collaborations among different communities. So Kubernetes and Mesos and other communities, and how they're starting, and what would be your aspirations for that kind of collaboration? Because it seems like, there's a complaint I often hear that there's just not enough people contributing to a single, community, right? And there's not enough users contributing, right? Contributing back. But we're talking about multi-cloud. You're going to need to have a lot of collaboration, not just within the community, but outside.
Yeah. I mean, there's definitely a lot of opportunities for, like when I think of, especially multi-cloud and multiple projects collaborating, I think there's a lot of opportunities to define some interfaces and some APIs that multiple of these projects could take advantage of. And I mean, thinking of multi-cloud, a lot of these projects are going to want to be able to do things like resize the number of nodes that they have underneath them, potentially take advantage of some of the networking functionality. And so, I do think that there could be work that's done sort of cross-project or even outside of any of these projects to just kind of standardize in some of those interfaces and APIs. There's definitely been projects in the past that have done some of this stuff. I'm thinking of projects like JClouds, and I know there's other ones as well.
Right.
One of the tough parts, and Murali was chatting a little bit about this earlier, of doing that though, is sometimes you get, the standard common denominator ends up not letting you really take advantage of some of the extra goodies that you'd get underneath the abstraction. So, if there's, in the hardware sense, if there's extra goodies from the CPU that you can't take advantage of, but in the cloud sense, I think the same thing might apply. And that's just kind of an abstraction conversation. How can you create a leaky enough abstraction that you can sort of sneak through and take advantage of the stuff that you want while still not pretty much being like every time you're using it, you're programming directly against that cloud. But no, I think that there's still an opportunity to elevate that conversation and create some projects there that multiple other projects could really take advantage of for doing some multi-cloud stuff. And I think that would be a great way for some of these cluster management technologies to collaborate as well, because they can all use that tech.
So are there projects that you think of that embody this now, this cross-community collaboration?
Yeah, actually, I think the container native interface stuff, CNI stuff's a pretty good example. I think there's a handful of projects that are actually adopting that, and that's really making a more viable ecosystem for other people to be on the other side of that interface. I imagine that we'll do more of it around storage as well, and I think that there'll be other things.
Any questions that about multi-cloud or complexity that anyone would like to pose right now? Did that help answer your question a little bit? Okay, great. Any other thoughts? Ken in the back, any thoughts about the multi-cloud out there that you have?
I guess when I think about multi-cloud and complexity and security, how do you secure those interfaces to the multi-cloud?
Who wants to take that?
It's super hard. If you're, hopefully you were at Adam's talk yesterday from the Mesosphere team. But yeah, so a lot of the things that we're building into DCOS for this are like a certificate authority, secrets management, with multiple backends so that you can kind of choose, pick and play. But it is super hard, and I think that there's a lot still to be done in this area, and like a lot that has not been done at all by like anyone in terms of like even new tech for this. But definitely, like if there was some sort of standard, then we could build off that too. In terms of like even just like getting keys and certs to places is hard. Like it's yeah. Intense.
So Jesse, I was listening to an interview you did on Arrested DevOps on containers. It had a bunch. You guys were talking about security quite a bit, and one of the things you brought up was like how hard it is actually to find the people actually to know how to do this kind of work, right? You know, how does that kind of play into these dynamics we're talking about now? Are you and how are you, how are you dealing with, trying to find people who actually can start to think through this, or are you mostly just looking for base skill sets and such?
Yeah, I think it's mostly just finding people with base skill sets and passion for it. Because, the hard part is like all these things, like once you start enabling TLS everywhere and you encrypt all the things, like you're breaking a ton of other stuff. So you have to be the one like that's willing to put up with that and then try to fix all the other things that are going to break. And when everyone comes to you, like, you just broke my app because I can't get to it now. So there's like a lot of patience and working together between different teams, because it's not just like one team building this out, it's the collaboration of all the different teams that really make it work.
Murali, maybe we'll just conclude with some of your thoughts on what you're going to be working on over the next 6 months to a year, kind of in the context of the multi-cloud. What are some of the big projects you're focusing on?
Yeah. The thing that we are looking at in Intel is providing the proper platform attributes, again, that allows multi-tenant, multi-workload, that's how I look at MTMW, multi-tenant, multi-workload systems to operate in a manner that is actually useful to the end user. And to that extent, we have distilled a bunch of attributes that, if you will. So we look at prioritization, reservation, capping, isolation, and security as some of the vectors that the Intel platform will be adding features on. So for prioritization, again, for example, we have this cache utilization monitoring and management, CMT and CAT, which allows you to get insight into how the CPU cache is operating. This is a level of visibility that has not been available before, and it offers a level of control that has not been available before. So again, and then we're also trying to look at the entire stack, I/O stack, memory, the memory management layer, and all that. And then we're also trying to make some problems easier to handle. Like, for example, I don't know if you're familiar with this concept, theory of constraints. It's basically a way to optimize complex systems. You try to find out what is the bottleneck that prevents optimization. And memory is one of the big things. And with Intel's 3D Crosspoint, we think that we can introduce entirely new classes of applications where, imagine what you can do with a terabyte of RAM for not much expense. It can totally change the landscape. So that's how we are looking at it. Our job is, again, to build the proper primitives with the right abstractions on the platform and expose the programmability hooks to the upper level layers so that orchestration tools can actually use these knobs and create the right enclaves, if you will, on the node so that multi-tenant, multi-workload scenarios can be properly executed. So that's what I'm literally working on a day-to-day basis, trying to figure all this out and influence the processor roadmap. And also we are communicating with the community and also creating tools like telemetry tools to extract platform information. And we open sourced one called Snap. I encourage you to take a look at it. It's a way to extract the platform telemetry and to make sense of what's going on. So that's how we're looking at it.
I actually had this conversation yesterday about next generation data centers, and I think that's what you're talking about.
Yeah, totally. I mean, my gosh. I mean, if you go down that route, it's I mean, there's just so much to talk about. We believe that optics, 3D crosspoint, and more integration and high-speed networking, it's going to change. It's going to change how people view things. I believe that entire hardware is going to be completely programmable. In fact, the FPGA movement that Intel has embarked in right now with Xeon and FPGAs is going to offer entirely new modes of interacting with the hardware. You're used to treating the hardware as, okay, the hardware is there and now I do stuff. But what's going to happen is intelligence is needed so that you can program the hardware to do what you want. Imagine that if you can download a piece of code that accelerates your imaging or a transcoding application or your machine learning application. Suddenly, it's not just about sending a job to a node. You now have a rich palette of colors with which to paint your picture, so to speak. So you can program the node exactly as you want. So Intel is essentially making the platform completely programmable, which is why our group is called SDI, Software Defined Infrastructure. So you can literally define the infrastructure that you need for the application that you're running. So that's where we are headed.
Ben, this is an interesting topic for me, this idea of the next generation data center. And you started your work, in your PhD program with parallel processing, correct? And then you moved into distributed computing. And, I'm starting to see more discussions about actual hardware coming into the discussion more so than ever before. And people are talking about things like open compute, right? And like how you can then, build these next generation data centers on these on this open hardware. Yeah. I guess I'm curious on your perspectives on that, in this conversation about the multi-cloud and the Mesos community.
Yeah, I mean, I think it's great. Getting back to one of the questions that was asked earlier about sort of vendor lock-in and multi-cloud. I mean, one of the tenets that we really have is how can we let the hardware shine? How can we expose up the great qualities of the hardware? And it's one of the things that's really tough to do in VM-based worlds, because VMs often are just at the lowest common denominator, which means you can't take advantage of a lot of those features. So, for myself, in fact, a lot of the time that I've been spent recently is thinking a lot about how to create even more sophisticated global resource allocation algorithms so that you can take advantage of some of these pieces of hardware. And it's really tough because sometimes the hardware is scarce. Like sometimes in the cluster, everybody won't be able to take advantage of all. You're only going to have 100 FPGAs in a 10,000 node cluster or whatever it is. And so there's a lot of work that needs to get done there, and I think it's a collaboration of figuring out what are the best ways to allocate these things out to different, these things being these really interesting hardware platforms, out to the different pieces of software that wants to run it, as well as the software at the higher level starting to adapt and having both algorithms for when they can take advantage of those pieces of hardware and when they can't. And either way they can run, and in some cases they'll be accelerated, in other cases they can't. And that to me is just bringing me right back to the parallel computing days, because we used to do that stuff all the time. You'd write an algorithm, and sometimes you'd be able to use a GPU, and sometimes you wouldn't, but you'd want to have everybody be able to run the algorithm. So you'd have different versions of the algorithm. That's part of your application. So, I think you were asking for a little bit more from software developers to do that, and we also are asking more from things like cluster managements to be able to figure out the right way to allocate the resources out. But the wins you can get at the end of the day, I think, are worth it. And so bringing the conversation full back to what we talked about at the beginning, which was complexity, I think figuring out the right abstractions and then letting people build on top of those is what will let people take advantage of all that stuff.
Jesse, any last thoughts on this topic? You must be thinking about this. You must start to see more discussions about hardware come into your conversations. And, in a security context, there must be all kinds of other matters that you're thinking about in this realm.
Yeah, I mean, I agree with better resource allocation. Like if you can define like using GPUs at certain places and stuff, it would be super cool, especially in terms of like the really cool like NVIDIA things that they're coming out with, or even like people who set up their own like Raspberry Pi cluster.
Right, Netflix.
It
yeah.
would be really cool. But yeah, not really any other thoughts on that.
Great, okay. Well, thank you all for participating, and thank you all for coming to the Pancake Breakfast. Thanks to Intel for sponsoring this. Thanks for the Apache Mesos community for having us here. You guys have a great day, and thanks for coming. We'd like to thank Intel, our sponsor for this week's show, and also the sponsor for the Pancake Breakfast that we did from MesosCon in Denver, Colorado, where this conversation was recorded. Learn more about Intel's vision of the multi-cloud and the future of software-defined infrastructure at intel.com. Thanks again, and I hope to see you back at the show. Bye-bye.